Hey everyone, so I'll be going over Leetcode problem number 1365, how many numbers are smaller than the current number. So it says, given the array of nums, for each nums at I, find out how many numbers in the array are smaller than it. That is, for each nums at I, you have to count the number of valid j's such that j is not equal to I and nums of j is less than nums of I. So what does this all mean, this kind of junk here? It basically means, so let's get the test case and walk through this. It basically means at a given index, given that number, how many numbers in this array are smaller than it? That's really all it's asking. So we could see at 8, or rather, to make this more clear, let's walk through this. So at 8, there's all these numbers that are smaller than it, and that's 4 numbers. So at this spot, it would be a 4. At 1, there's nothing smaller than it because it's the smallest number in this array. So that would be 0. And then at this 2, there's only the 1 that's smaller than it. So this would be 1, same with the other 2. And then this 3, only these 3 numbers would be smaller than it. So this would be 3. And if we look at this, when we derive this, walking through it, this is actually the same as this output down here. So this is the logic we want to go for. So basically, intuitively, what you'd think to do is go through all these numbers, then check every other number and see if it's smaller than it, then increment some count. And you could do that, but that would be n squared because you have to go through every number for every number. So there is a way you can do this linearly. So basically, what we first want to do is we want to count the numbers. And I mean, for each number, how many times do they appear? So there's 1, 8, there's 1, 1, there's 2, 2s, and there's 1, 3. So once we have that information, things start to get interesting. So let's do that, and let's set up our counts array. And we do it like this because if we go down here, we can actually see there's a constraint on the number sizes, and they can only go up to 100. So we'll represent the counts like this, and to fill the counts, it's very simple. We'll just go through each num in nums, and then we'll just simply increment the count that we've seen it at. So now that we have this, that's all fine and everything, but what does this look like and what does this do for us? So after we do this, this should look like this. So let's say that our input was this. And if our input was this here, let's say our counts is currently this. We haven't filled it yet. So this is the count for 0, count for 1, count for 2, count for 3. So we encounter a 1, the 1 goes to 1. We encounter a 2, the 2 goes to 1. We encounter another 2, the 2 goes to 2. And this is 1. So how do we read this? There are 0 zeros, there is 1 1, there are 2 2s, and there is 1 3. So that's how we read this. Why does this help us? Well, it gives us all the information we need to solve this, because now we can, so this is index 1, 2, and 3. So these are the indices, these are the numbers, the counts that we've seen them at. So at 3, so what does this tell us? At 3, we want to know how many are smaller than it. Well, it's just the sum of the numbers on this side. So there are 1 plus 2 numbers smaller than 3. So basically, and then at 2, there is 1 number smaller than 2. So this is exactly what we want. And to do this, we have to keep a running sum. So if we keep a running sum, it would be 0, 1, then this would turn to 3, and then this would turn to 4. So basically, say there was now a 4, so there would be, for 4, there would be 4 numbers smaller than it. And then at 3, there are 3 numbers smaller than it. At 2, there's 1 number smaller than it. So that's kind of the logic we're going for. So to get that running sum, it's very simple. We're just going to go through counts and just take the current number and then add it with the number before it. And we start at 1 for this loop because we don't want to start at 0 because we'll get index out of bounds on this. So now that we have that information, it's very simple from here on out. And we're going to actually just return nums because we'll put the answers right back into nums. So basically what we want to do is we want to go through our nums array. And the idea here is we want to put nums, and we're treating it as the result array. We want to put at nums the sum of the numbers, or the sum of the counts of the numbers to the left of the current. So this would look something like this. So counts at num of I minus 1. So this basically gets the current number minus 1 in the counts, and it looks how many numbers were smaller than this. Now this works fine, but what if nums of I is 0? Then this would turn to -1 and this would be out of bounds. So that's no good. So to do that, basically we can just do a check here and see is nums of I not equal to 0. And then if it's not equal to 0, we can set it. And if it is equal to 0, it'll just be 0 anyways, so it doesn't matter. So then this should get us exactly what we want, just walking through that logic there. And we get accepted. Let's go ahead and submit this. And we'll see 97% runtime and also pretty good on memory as well. So I hope you guys enjoyed, and I hope this was simple. I just wanted to break it down and make this as clear as possible. So I appreciate it as always, and I'll see you guys around.